Okay, so next up we've got Ted Zoli from HNTB, and he's going to be going over some built-up press brake tub, formed tub girders.
I'll try to go quick here to save some time for questions. So this is a project that had as sort of a research goal, and it's going to dovetail a lot with what Jason was talking about, is can we really take deep advantage of internal redundancy and then also really build on the work of people like Carl Barth, who've been spending a lot of time with press brake tub girders, and this is really an extension of all of that. And so another piece that's always bothered me is we have this accelerated bridge construction where we replace the bridge, and this was one in New York State, where we replace the bridge in a weekend, but it took us 2 years to get ready for that weekend, and that's, in my view, accelerated bridge construction, but it's not accelerated bridge fabrication, right? So for me, part of the goal here is can we really dramatically reduce the time it takes to fabricate steel bridges? And you heard a little bit about that this morning from Jeff Carlson, this idea about how do we get faster? And I think that's really crucial. And then we're also building on this work that was started by Carl Barth maybe 20 years ago. And this idea of folded press brake tub girders, now Valmont's got a shop that's set up to build press brake tub girders. They're very competitive, standardized sizes and so on. There's some interesting issues with lateral bracing, with top lateral bracing that Todd talked about that I'll mention very briefly. But this is now prime time. I would say we're seeing more and more of this. So there's a bundling projects in Michigan against the pre-stressed beams or slabs and tub girders. There's 15 projects. Every contractor bid tub girders built to every one of those in a bundling project. Now there's another bundling project out to bid. And so we're starting to see real movement in terms of the industry headed towards press brake tub girders as a strategy. And just to walk through the workflows, what's in Valmont's shop is this idea you start with ASHTO steel, something that I want to talk a little bit about why I don't think that's the best idea. You're using a press brake to form the tub. In this case, you have to flip the tub around, which is a little complicated. They're also cambering, so that bottom left is cambering, so they're actually able to introduce camber into the girder. And then you see shooting shear studs and then dipping after shear studs, which some people take issue with. So this whole question about, post-galvanizing, are we affecting welds and weld toughness that we can talk some about too. But that's their workflow. This has become very, very cost effective, and it's an interesting strategy that we're using in other places. But now I wanted to really think differently about and really a different workflow, which is now let's say we want to invite new industry to building bridges, and we looked at transmission pole manufacturing and that capability and say, could we use transmission pole manufacturing skill sets to build bridges? And in this case, part of what we're fabricating so we're fabricating a web, and that's the Z-shaped or S-shaped plate. I don't know if this works. And so it's similar, like that's a half shape of a typical transmission pole that Todd talked about the welding issues associated with that. But the nice part about it is they stack like Pringles on a truck, so you can ship these S-shaped webs stacked. And then this is actually in the right hand, is that after they're assembled, you can either ship them whole or you can assemble them on, shake them out and assemble on site. I always come here and say we're so, in the industry, we're so appreciative of all the work that Texas does. I want to say thank you again, not just Todd's work on tub girder lateral bracing, but this is Eric Williamson's work on twin girder redundancies. And if you're not familiar with that work, check it out. It's absolutely unbelievable how redundant twin tubs are and what he had to do to get the tubs to fail, trying to, after the flange was cut, the web was cut, explosively removing the supports. Even after all of that, I think it took 5x of HL93 loads to get failure. So tub girders have this incredible amount of redundancy. And then what Jason talked about, the work that Rob Connor's done on how difficult it is to get not only cracks to propagate in good toughness steels, but built up sections are just magical. And so we've done a lot of work in other places. And when I talk about stacked girders, and this picks up a little bit on what Jason was talking about, this is a little different idea, but here we have stringers and the top part of the floor beam being the same cross section, and Ronnie fabricated this, and the lower section being the added piece. So these are stacked in that sense. And we see this as both internally redundant and also it allows continuity. So one of the things about straddle bents that I challenge everybody with is usually the problem is we don't have enough headroom, right? So the idea we want stringer continuity, not having the stringers on top brings the stringers down, and this is a strategy to do it. And so I think you can get internal redundancy that way as well. So the piece for me also was that we should stop cambering things, and when we think about curved sections, why don't we think about things as piecewise straight? And so part of the logic for me with rapid fabrication is also rapid ability to transport. We don't have steel fabricators all over the place. We're putting stuff on trucks and shipping it. So this idea that things are about 45 to 60 feet long, they can be shipped on a truck. And at that point, with such short segments, if you're using bolted splices, there's no reason to camber and there's no reason to curve. And so all of this is really intended to be extended to that idea of stop cambering, stop curving, just build these as piecewise straight and use bent plate splices. So this has been a research program with Notre Dame, HNTB as a designer, Nucor, SSAB, and Delta Steel as the industry on the fabrication side, and then Indiana DOT. This is a project for Indiana DOT, which I can say comfortably does not build steel bridges. So it's the perfect place to do a research program on being competitive with pre-stress because that's all what they do. The magic about Delta Steel and something that I want everybody to think about, and this captures the discussion I had with Mark Haight, is that they have in this one location in Fort Worth like 10,000 tons of steel on the ground. Not a mill order. They don't go to the mill and say, here, we've got a project. They have the steel on the ground. So the idea for me is they can both fabricate on demand. Hey, I need this web. And they also could stockpile, right? Because they're set up for that. It's just a different industry. So in my view, the idea that we could be set up for very rapid fabrication, meaning on demand, like today, I could get a web, or I could have these webs in stock where I can just order them. And so this demonstration project, we did a pair, and this is, to Ashley Thrall's in the room and Indiana DOT, for us to take what's really research and turn it into 2 demonstration projects in about a 3.5-year period is remarkable. In my view, that should be our goal. Let's not talk about things. Let's not do research on things. Let's get them built. I think there's nothing like built projects. So we were replacing these 2 bridges. One was a single span, about 100 feet. The other was supposed to be a 3-span. We redesigned it as a 2-span, so we eliminated a water-based pier, and this was straight-up replacement of pre-stressed beam cross-sections. This is the cross-section in the shop. These are the dimensions, not quite so important, roughly about 38 inches deep. And then the flanges, as you see, are top and bottom, and the simple span those were 1-inch plates. And in the continuous part of the 2-span, they went up to 1.5. So the idea behind this, and the problem with folded plate tub girders, you can't change the cross-section. Here we can. We change the flange sizes just like you would in any other sort of bridge design. And so the other thing that's maybe strange and why we're not using Astro Steels is sort of a long story, but it turns out that pole manufacturing has in stock 55 KSI webs, and those webs are really set up to be bent. So our argument here was let's do this demonstration project with material that Delta Steel has on the ground, not have a special mill order, and we'll talk about that. But the flanges, so this is kind of a reverse hybrid section, right? You've got flanges that are less strong than the webs, and that doesn't mean much in the grand scheme of things. For me, what was more important was to have steel with good low temperature Sharpies. And this idea, those steels are designed to be bent to tighter radiuses. This is the greatest steel manufacturer in the world and one of their competitors providing similar materials with similar very high toughness. And what I want you to know is a transmission pole has typically got a Sharpie in the hundreds at -20. Yeah, and we're specifying something like 25 foot-pounds at +40. So they're starting with extremely good steel, and this happens to be low carbon steel. And low carbon steel, and this is some of the work that Dave Stoddard did on cold bending. in cold working, we have this 5T limit or 7.5T limit. And what he finds, and even down to 1T, and this is something to do with plastic bending strain, but he finds low carbon steels you can bend with very little loss in toughness. And that loss in toughness for me can be thought about as a temperature shift. So if you're starting with really good toughnesses at low temperatures, that's the kind of steel you want to bend. And I think in some ways we're under-specifying ASHTO steels. So we bent these to actually about a 3.5T radius. Our argument is we standardize the bend radius. So regardless of what web we're making, it's all bent to the same radius. And in this case, we're using up to, say, 5/8 inch. We're 1/2 inch, 5/8. We looked at 3/4, but we feel like 3/4 doesn't buy us much. And so, this is these are the tubs in lay down. So we did full assembly. I'm not sure it was required, but we ended up doing full assembly. We were not sure how tight the tolerances were with the webs. We only had one web out of, and this was maybe 25 segments. We had one web that needed a fill plate. That was it. So the ability for Delta to produce very accurate webs was clearly demonstrated. We had some full depth end diaphragms, and some of that I think is just, for us at least, was strategy. We didn't get into too much of Todd's reduction in lateral bracing, although it was a place I wanted to go. It just wasn't the right strategy for a research program to get into that too much. We also we couldn't really fit K diaphragms and get inspection access, so we wanted the ability to be able to get inside the box. That's why full open diaphragms. And then we use semi-integral abutments. This is Indiana DOT's semi-integral abutment strategies, but we feel full integral and semi-integral, this technology is perfectly well suited for that, and you get something that's super robust. So we did not do any cambering. So those are all piecewise straight. We just had different gaps, top and the bottom of the splice. We did full assembly. We pulled out the supports, and we were within a 1/4 of an inch, or maybe it was 3/8 of an inch on camber. Yeah, so we're piecewise straight. So we proved, hey, there's no issue with doing this. I'm not sure why we're probably cambering girders too much. And then we did do, in the end, we did do skew diaphragms here, although I think if I had it to do over. So the problem with skew diaphragms is you need bent angles. I just don't think it was necessary, so we would probably go back and not do this. There's a video to play here that I'll skip through because it's long and not all that necessary, but this is the, well, it might not. Anyway, that's their fabrication workflow. It's very straightforward. We're burning holes before we bend. So every hole that we make is before we bend. We bend afterwards. They're bending to high precision. And basically, that does, yeah, that's what it was. I don't know if it lets me go forward. No, forget it. So those are the bent webs. Those are the first two in fabrication. You can see some of the marks associated with the air gap press brake bending. So you have these longitudinal elements, but all with tight geometry. As I mentioned, laydown went great. They were hot dip galvanized. We were concerned about, hey, how much distortion would we have in hot dip galvanizing? Turns out none. These are ready to be shipped. I've talked with other contractors, and other contractors that say, well, look, we would shake these out on site and bolt them up. There's no reason to go through a fabrication workflow, and we think that's the fastest way to home. But for this demonstration project, we had full shop assembly in segments, obviously. And then there's the girders ready for a deck. There's the completed first structure. Second structure was completed about a year later. Also, this was stage construction, so you can see we had to demo the bridge in half. This is built in halves, stage construction, stay in place forms in between the girder lines. Ashley did a whole bunch of instrumentation of these bridges, yawning. I mean, hard to find stresses in terms of internal redundancy and the faulted state and all of that stuff. We were full live load with complete web fracture or complete flange fracture, still yawning. this would be infinite inspection and no reason to do any of this. Now, we did not design these. I mean, I think these could be designed more aggressively for a research program. I would also suggest that one of the takeaways we found was that we could do with much less lateral bracing. So Todd's work on just lateral bracing in the end regions makes perfect sense. The lateral bracing wasn't doing much in the meantime. Even the K-bracing or the diaphragms of every other bay, for bridges of shorter span, I think you could even go further, like the need to be shape holding away from the supports is very limited. So in the end, you know, where we started or where we're sort of finishing up in this kit of parts is that our idea is that you would be able to produce webs in our circumstances, and this is really following a workflow from a transmission pole manufacturer, is that you'd have webs in 6-inch increments, and so the web thicknesses for us range between ½ inch up to 3/4, although I think we dropped to 3/4 finally because we found it wasn't necessary. You can get spans in the 275 simple span range up to 300, maybe 325 continuous. So there's nothing that limits you in terms of span ranges, even with those web thicknesses. Just constant bend radius, so that bend radius works. We bent 5/8 inch plates, I should say that. So ½ inch is actually a better bend radius. And then the flanges, this is interesting. So a pole manufacturer has flange plate also in stock. That flange plate is used for base plates. That's why it's 50 KSI steel. Didn't realize this. So if you keep in 1/4-inch increments, they have on the ground plate that they can drill. And so we can talk a little bit about hole drilling, but they can provide the plate as well. For us, our thought process was a conventional steel fabricator would fabricate the flanges and they would just purchase the webs. And so the other thing is that we're talking about standardized hole patterns. So the flanges have standard hole patterns to develop horizontal shear. And so what we're trying to do is maybe have more bolts than we need so that we can accommodate any set of circumstances. And so the overall logic would be, instead of going to the store and getting a rolled section, you go to the store and get a bent web, and now you can fabricate a box. And here, by the way, we had no welding. So when I say no welding, like no welding, there was not welding at all here. So you might argue, well, that doesn't make sense. There's lots of advantages to welding. What we feel is that if you're shaking these pieces out on site and you're going to essentially fabricate on site, that this offers that opportunity. And when it's really an emergency where you really need that reduced time frame, we think that's a big advantage as well. And so wrapping up here, there's lots of acknowledgments, mostly to Indiana DOT, and then Ashley's really good about making sure everybody who's involved is acknowledged. I'm less good at that. And then finally, you know, Nucor and SSAB donated steel, Delta and Inframetals did all the fabrication for free as part of this demonstration project. And that was fairly painful. I appreciate all of their inputs. It seems like anytime we do something for free, the steel price spikes and you know, Delta Steel gets busy with transmission poles. And so it was really fairly difficult to squeeze this demonstration project in, but all successful. And I would say that Delta has gotten very interested and have already expanded their capabilities so that with a larger press brake and more capabilities so that they see there's real market here. Our goal is to have any transmission pole manufacturer able to fabricate these sorts of webs, and that this is then just bolt-up construction. And just to end, for me at least, this idea that we maybe abandoned bolted sections a little too early, and I get that post-World War II we had lots of welders and lots of capability with welding, but I have to tell you there's a huge advantage to bolted up sections in my view, just in terms of internal redundancy, to build on what Jason said, but also for me, this idea of how long it takes and how much complexity we introduce, especially, and I think tub girders is probably where we introduce fabrication complexity, where we might be looking for fabrication simplicity. Once you go to the sensibility about bolting up, you really have to start simplifying things. And that simplification, in my view, actually is very helpful. It's very helpful to think about maybe we're doing some of our welded stuff too complicated as well. And, we forget we have haunches, and haunches are for correcting little geometry. And the last thing I'll leave you with, because the Delta Steel and others and transmission pole guys are used to putting things on trucks, everything in their shop, including the plate they have lying on the ground, is set up to be put on a truck. And so for me, when you think about pole manufacturing or even bridge fabrication, when I bet many of our projects are 250 miles away or more, having stuff that's really set up for trucking logistics is, I think, better all the way around. So I'll stop there. And then questions for Jason and I guess, yeah? Yeah, Ronnie.
We started looking at smaller tons.
Right.
Key thing is you get a shallow. So for like 100 foot, you could say 1.5 feet.
That's right.
Really nice.
That's right.
But one of the things that came up a lot is inspection. We'd say, well, hey, we got this redundant truck, we don't have to worry about it. But, inspection is always one of the time. And if you go back to your diagram,
So we went through all of this. So this business.
Yeah, here.
Yeah.
Exactly. But
Yeah.
go back. Yeah, here. What we did is we came up with one that was out of on the bottom plane,
Right.
which would free up. So you can put a drone all the way in there.
Yeah, so we sort of looked hard at this, and what we found was that every state standard on inspection access to tubs is different. We found one good reference and it's IBC, and there's another emergency egress code that had what I would say more rational limitations on what access you need into a box. And so this we think is kind of the smallest you'd go. Otherwise you'd go press brake tub grid, forget the bolt up, right? Anything that's less than this depth, there's another product to market. So we wanted to start here. But this meets all the egress requirements. It just means you need a plate diaphragm. The idea, if you ask me, what is the bottom flange connection doing? Absolutely nothing in these circumstances, I would say, for the most part. We didn't look at that hard, but it's a fair question. For us, I think we're headed towards the deeper part of the market, in which case you can do, you have enough room to get inside the box, and we're expecting people to, but it's totally, and it would be less likely to trip and so on. Yeah, this is definitely a crawl in. Yeah, I'm small, so everyone thinks I make things too small. So, other questions? So this one, the two span the long span was 109, if memory serves me, something like that, over 100. Yeah, and that two span continuous is the dumbest system ever, right? No one would do a two span continuous on purpose. Part of it was we wanted to demonstrate that we could handle large negative moments and eliminate a pier in this particular case. These are piecewise, everything is piecewise straight. That's right. That's right. Oh, yeah, these are kinked. These are bent. Yes, yeah. These are, so the gaps are different. And so Ashley's done a lot of research on bent plate connections, and you can bend plates a few degrees before you're into circumstances where anything is wrong with the plate. These are much, much less than that, but these are everything fabric. So Delta Steel fabricated the splice plates, just to make sure that that's clear. All those splice plates are flat, but they're bent when you bolt up. And every one of these is kinked. And my argument here is not could you just kink in elevation, but you can kink in plan too. So you can build a curved tub just as easily as you can a tangent tub. There's nothing magical. And if you had a very tight radius, let's say you're 300-foot radius or something like that where you had significant kinks, then I think you pre-bend the plates. But there's nothing wrong with that. We've done lots of kinked girders that way, and it works just fine. And you'd pre-bend, I mean, there's circumstances where you pre-bend the plates, but, you know, we're talking to press brake guys. That's what they're good at, bending shit, so sorry. Bending stuff. I'm from New York, right? To swear a little bit. Other questions? None for Jason? All right.